In this quick video, we're going to find out how to check whether a quadratic equation has real roots or not without having to actually solve the equation itself. Here's our quadratic equation. So it's any equation of the form ax squared plus bx plus c, where a, b and c are real numbers and a is not equal to 0. We know that if we've got one of these, one way to solve a quadratic equation is to use the quadratic formula. So x would be equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. This would give us our roots. We could then use this to solve the equation and find out if the roots are real or not. But there is a quicker way just to quickly check whether the roots are real or not, and that is to use the b squared minus 4ac under the square root there, which we call the discriminant. Now there are three ways this can be. Our b squared minus 4ac could be smaller than 0. Now if it's less than 0, we're square rooting this. The square root of a number less than 0 can't be a real number. It would have to have an imaginary element to it. Hence, x itself can't be real. So there would be no real roots to our equation. Our graph would look something like this. It's not crossing the x-axis at all. There's no real roots. Now, if b squared minus 4ac is larger than 0, well, we can square root any number larger than 0. We would get two answers for x. We'd get the positive root part and we'd get the negative root part. Hence, x would have two values. So we'd have two real roots and we'd have a graph that looks like this, crossing the x-axis and then coming back again. So far, we've looked at smaller than or larger than, but obviously b squared minus 4ac, our discriminant, could also equal 0. Well, if this is the case, then the plus or minus part of our quadratic formula doesn't have an effect. It's just plus or minus 0. So our x would just equal the minus b over 2a part. Hence, we'd only get one answer, which we call a repeated root. And this is when our graph looks something like this. It just touches the x-axis in one place. So it's got one root repeated. Let's put this into action with an actual quadratic equation now. We've got 3x squared plus 4x minus 7 equals 0. We want to see how many real roots it's got. Here's our discriminant, b squared minus 4ac. So b is equal to 4, the coefficient of the x. A is 3 and c is minus 7. So 4 squared minus 4 times 3 times minus 7 equals 100. This is larger than 0, hence we can square root it and get a real number. So there are going to be two real roots. Here's another quadratic, so x squared minus 4x plus 6 equals 0. So this time taking a equals 1, b equals minus 4 and c equals 6. We get our discriminant is minus 4 squared minus 4 times 1 times 6, which is minus 8. So this is smaller than 0. Hence, if we square root, we're not going to get a real number. So this one would have no real roots. If you've enjoyed this video, don't forget to subscribe to the Doing Maths channel or check out some more of my videos by clicking on the links here.